record this. All right, let's take a look at what we need to go through today. Whew. All right, so we need to talk about manometers today and pressure. And then tomorrow there is no Zoom, there's a Mythbusters. Let me show you what that is. So you won't actually meet for the Zoom. You'll be able to go directly to the Mythbusters, and basically you will open up this screen right here. And you will have this opened as well. Or you can print this out, or you can just write it on a different sheet of paper. And basically you'll answer these questions. Note that they do need to be in complete sentences. So if you've never watched Mythbusters before, basically they're going to test a myth here. You'll watch this 25-minute video describing the myth of what they're doing, describing how they test it, and then tell whether it's plausible, which means that it could happen, whether it's confirmed, meaning that they've found evidence that it did happen, or whether that the myth as described could not happen, meaning it's busted. Then you'll tell why. Well, obviously, if it's confirmed, then you'll sit there and say, well, because this happened in wherever it did. If it's plausible, you'll tell, well, it could happen, but the circumstances maybe are not very likely, or why it probably wouldn't happen. If it cannot happen, then you will say, this is why it cannot happen. It just can't, right? You will use the concepts that we've talked about these first 2 days that are talked about in the myth itself. Or if you want to use something from last semester as well that your other teacher talked about or I talked about, you can. Basically, this question right here is, why would we watch this during class time? Why would we use 45 minutes of class time to watch this? Last but not least, 6, this is your chance to get a little artistic if you want, but you can describe an event from your life or something you've seen around you that would basically talk about this myth, like would basically give you this idea of what this myth is about, or something that it reminded you of, right? The way we submit things in this course is we do a file upload. So if you use the stylus and stuff like that to write on the what's it called? The Chromebook, then you just basically submit that right into this assignment. If you print something out and you write on paper, then you need to use a document scanner. A document scanner, if you have like a phone, you can look up for an app for document scanner, but a lot of times there are easier ways. Let me see if I can get this up here. Huh. Give me 1 second. Whew. So if you take a look on your iPhone or whatnot, under a program called Notes, it brings this up. Down here is how you add a new one. And then you would click the camera and scan documents. See right there where it says scan documents? What that will do is that will bring up your camera, and you'll be able to basically raise it up, take a picture, and then you can see it's got the actual document outlined. If it's not perfect, you can like stretch it out to that document. But what that does is that allows you to keep that document perfect, just like it should be. And then it will actually be able to read it and stuff like that. You'll be able to see everything on there whenever that's sent. This has more definition than your camera normally does. It uses a different program. So whenever you submit something, Make sure you use a document scanner. The other cool thing about the document scanner is it allows you to also basically, if you have this one here, it allows you to then take another picture, let's say of the next page. You can see this one's a little bit more off, so we'll pull those down so that it actually matches up with the page. And then what that does is that puts all of that into the same file. That way, this page and this page are both in the same file. And then I can send that to myself and submit it. But what that does is that allows everything to be seen a lot better on the file itself. All right, let's see how you fared yesterday on these. So we had 785 millimeters of mercury. Every 760 millimeters of mercury is 1 atmosphere. We have 3 significant digits with that. So that's going to be 1.03 atmospheres. Here we have 811 torr. Every 760 torr is 1 atmosphere. So we're going to divide that 811 by 760. We're going to get 1.07 atmospheres. 3 significant digits, 3 significant digits. Next one, we want to go from 22 psi, every 14.7 psi is 760 millimeters of mercury. So we're going to take 22 times 760 divided by 14.7. We get 11,000. We only have 3 significant digits. We get 1,137, which will round to 1,140 millimeters of mercury. Then we got 3.21 atmosphere. Every 1 atmosphere is 760 millimeters of mercury. 3.21 times 760. That's 2,439, which we will round to 2,440 millimeters of mercury. Questions there?
Yeah, for number 5, why would you not put like 1 I guess atmosphere instead of like the 14.7?
Yeah. So what we have here is we have to make sure that whatever the unit we start with matches the unit we want to get rid of. So we don't have atmospheres here. Just like here, we didn't have millimeters of mercury. So we can't just follow the same thing. We've got to look up here and say, okay, 14.7 psi. This is psi. There are 14.7 psi in 760 millimeters of mercury. Let's do something just to make sure you understand. If we have 2 feet, right? Well, we know that 1 foot equals 12 inches. And we know that 3 feet equals 1 yard. If we want to get inches, which one of these are we going to use? The top or bottom? We know this one gets us to yards. The top one gets us to inches, right? So we know 1 foot has to go on bottom, otherwise that's not going to cancel, is equal to 12 inches. Same thing here. We have pounds per square inch. We need to put pounds per square inch on bottom. How many pounds per square inch? 14.7. All right, down here, convert the following to Kelvin. If we take a look, negative 35. So we have negative 35. We're going to add 273 to that. We get 238 Kelvin plus 273, just like the formula says. 25 plus 273. We get 298. And keep in mind that since this goes out one decimal place and this 273 is a good number, we need to go out one decimal place for that as well. Going from Kelvin to Celsius, well, we subtract 273. So it's going to be minus 273.00 degrees Celsius. And 112 minus 273 gives us negative 161.
Mr. Jackson,
Yeah.
so we don't worry about sig figs there, right?
We are worrying about sig figs. This goes to the ones place, so this goes to the ones place. This goes out 2 decimal places, so this goes out 2 decimal places. Remember, addition and subtraction are based on decimal place for significant digits. Now the cool thing is we're looking at this 273 as a perfect number, just like we're looking at these as unlimited significant digits. So instead of being 273, this in reality is 273.00000 to infinity. So when we add this 25.0 to it, whatever number we have there, that's going to be our determining factor for our significant digits. It's going to have the same number of decimal places as whatever number we start with, because it's addition subtraction rules. Yeah. All right, let's take a look at manometers. I need to go back here and grab something I think we can use for our manometer. So you might want to click it on so that you can see my screen pretty well here. And basically what I have is an open tube, right? And if we take a look, you should see that as I move this back and forth, the level of that water stays the same with compared to each other, right? Even if I take this side and pull this side way up, that water stays the same. And watch this. If I seal off this side, and then we take it and pull it like this, oops, I lost my seal. There we go. You can see that this is now sealed, but this is open to atmospheric pressure. So the pressure inside of this one is actually less than atmospheric pressure. Atmospheric pressure is pushing down on this level of the water, keeping it all the way down here. All right, too bad I don't have like a white shirt on today. Now take a look here. So now, watch this. If I take and I put higher pressure in there, you can see I just forced it up this way, right? This is still the open end, right? So check this out. If I take and do it like this, this is now the open end still, but look at my level. The pressure I have in here is actually higher than atmospheric pressure. So the pressure pushing down on this is less than the pressure in this part of the tube right here. That's why it's pushed that water up. That's how a barometer works. Basically, you have a gas in here, and if the pressure here gets higher, right, you can see it move. If I put higher pressure here. If I put lower pressure here, you can see it move as well. So if I pretend like it's a straw or whatnot, you can see that it moves toward my mouth. That's a barometer. That's also the way a manometer works as well. So pretty easy. Now I just need to find somewhere for this, to use this for next period. There we go. That'll work. So it doesn't spill out everywhere. Hey, there we go. All right. So let's take a look, just like our tubes here. I'm on the page number 2. So if we take a look, problems 1 and 2, calculate the pressure of the gas in the flask connected to the manometer. And so yesterday we talked about atmospheric pressure, and we said how every single thing in this room that I'm in has got about 14.7 pounds pushing on it per square inch. Well, for all of these problems in one, it's saying that there are 730 millimeters of mercury pushing down on everything. Since this is the open side, that's 730 millimeters of mercury pushing down. Since this tube, the liquid in there is forced out of this container, does that mean the pressure in here is higher than or lower than 730? Remember, areas of high pressure move to areas of low pressure, right? You don't suck a tire, you blow a tire because the pressure inside the tire is too high. Or if I keep putting more and more air in here, the pressure in here gets too high and it causes it to pop, right? So I'll turn on the chat just in case. You guys are using the chat method to communicate with me. But if this is 730 pushing down here, is this greater than or less than 730 inside of here? Greater than is correct, right? It's pushing more than 730 down. That's why it's forced this down. Well, we can measure the distance from here to here to find out how much more than 730 it is. So 127 minus 84. We get 43. So that is a difference of 43. We said it is greater than, so the P here is greater than the P of the room. How much is it greater than? 43. So 730 plus 43 is 773 millimeters of mercury. So it's still 733 or 30 millimeters of mercury pushing down here. Is the pressure in here greater than or less than the 730? So the P here is greater than or less than the P of the room. I'm just going to call this P of B. Notice, again, think about you using a straw. Maybe sometimes you had like a crazy straw or whatever. You could control the pressure to move that liquid through that straw, right? If you create a lower pressure inside of your mouth, it comes towards your mouth because the force on the surface of the soda is pushing it down. If you all of a sudden exhale into the straw, you create more pressure in there, which causes it to go away from your mouth because it's fighting the pressure that's still on the surface of that soda. So as I said in the chat, P of B is less than the P of the room. So that means that we need to find out how much less than. So again, we go from 130 minus 26. We get it as 104 less than. So if the P of the room is 730 and P of B is less than that, 730 minus 104 gives us 626. So the P in here is 626 millimeters of mercury. Biggest question of the day. Pressure in here, is it less than or greater than the pressure on the outside? Less than or greater than the pressure on the outside. Is this sharing the right one? Weird. It's not showing me sharing. Let me make sure. There we go. So here, pressure inside versus pressure outside, which is greater? And Maddie does it again. They are equal. Good. And whoever was, yeah, they are equal. The pressure is equal, right? It looks just like it does here. The fact that both of these ends are open means that that pressure inside and outside is equal. So that means that the pressure inside must be 730 millimeters of mercury. Must be 730 millimeters of mercury. Questions about that? So what is meant by atmospheric pressure? Well, above us are all of these gas particles that make up our atmosphere. The oxygen, the nitrogen, all of that stuff. That's what causes this pressure. Gas particles that make up our atmosphere cause this pressure. What is meant by it, it is the force of these gas particles colliding. With everything, with each other, with you, with, you know, the barometer over there on the wall, all of these different things. Oh, I just gave you number 4. This is a good question. Is atmospheric pressure the same everywhere on the surface of the earth? Anybody want to attempt that one? Is it the same everywhere on the surface of the earth? Think about this. If I go down into the Grand Canyon, or if I climb up to the top of a mountain, do I have the same amount of particles above me in our atmosphere? If I'm up on a mountain, I don't, right? I have less particles above me, so there's less pressure on top of me. Imagine if you lay down and then you have your friend lay down on top of you, and you have another person lay down on top of you, and another person lay down on top of them, and then, you know, basically have what, like in football, they call a dog pile, right? The person on the bottom is feeling the pressure of all those people on top of it. If we go up on a mountain, we're not going to feel that same pressure. We're not going to feel the same pressure that we feel down here. This is also why, if you were to fly or something like that, a pressurized cabin is not the same pressure that you would have down here. This is why your ears pop and stuff like that. And then when you return to the surface and they open the cabin doors, you know, your ears pop again. Or if you dive down underneath the water, like if you try to touch the bottom of the swimming pool here at North Central, you not only now have the atmosphere above you of air, but you also have, 10 to 15 feet of water. That's what's pressurizing your head. That's why it feels like it's going to crush your skull. So keep that in mind. The assignment for tonight is to finish up these problems down here at number 4. And then tomorrow, again, no Zoom. You are required to go and do the Mythbuster. Basically, you watch that movie and fill out that sheet using complete sentences. I will have the Zoom on if you need to come in and ask questions or whatnot, or if you're having trouble with that. But you don't have to report to the Zoom. That's what no Zoom means. It doesn't mean that I'm not here. It just means that you don't have to report to it. So keep that in mind. Basically, what I do for checking attendance on days that there is no Zoom is I just check that you checked into Canvas, because you would need to check into Canvas to do the activity. If you have any questions, by all means, stick around. Otherwise, have a great day, and make sure you get those very few problems done. It's just 4 problems. Take care.